This video is going to cover exporting a STL file from Fusion 360 for the purposes of 3D printing and then opening it in Ultimaker Cura and some of the basic settings. An STL file is essentially a universal mesh format which a variety of different programs, whether from Autodesk or other manufacturers, can open and utilize. So it's not proprietary. However, once you save it as a mesh file like an STL, you do lose a lot of the geometry and features. So it's important that you also have a version of your solid model still saved. Otherwise, it can be quite difficult to come back from. Essentially, this surface here would become a load of triangles. You wouldn't be able to create a sketch on the plane and edit it as easily as you can with a step or a Fusion 360 native file format. There's two ways to get an STL file from Fusion 360. So if we click this file button up here, we can either use export as an STL or 3D print. Exporting as an STL, if we clicked export STL, would essentially, and go export, would essentially use cloud translation. So it's not a fast thing, it might take a few minutes. So instead we can go file 3D print. And here we have the option of changing the refinement. So this will allow us to change the size and resolution of the 3D printed STL file. Importantly, if you need to maintain high precision, or you would actually want this to be on high. Essentially, if you've got a circle or something like that, a lower precision refinement export would essentially divide it up into a lot of lines. And so, if it's on very low, your circle may look more like an octagon, which you don't want. The higher the refinement, the larger the number of triangles that are going to be, and the more round and more normal the profiles are going to be. But on the other hand, that is also going to greatly increase the size of the file. It will increase the time it takes to export, and it will also increase the time it takes for the slicing software or Ultimaker Cura to actually process it. But for most things, you can leave it on high, and essentially we just select the body. You might have multiple bodies, but we've just got this one selected. And then we're going to click Send to 3D Print Utility and go OK. And we can actually choose where to save this. So now what we can do is we can go over to Ultimaker Cura and we can click Open. And now it has actually imported this STL file onto the bed of the printer, and it's put it directly in the middle. As we can see, for a part like this, the orientation of printing would be important. FDM 3D printing, or fused deposition modeling, essentially functions by creating the object layer by layer, similar to a 2D printer, a paper printer, printing multiple times over the same area. For that reason, FDM 3D printers don't handle overhangs very well. So if I've got this big cavity in here and I rotated this around to be 3D printed this way, that would cause quite poor results, as there would be a significant overhang in this area. We could fix that by adding support material, but that would be fairly unnecessary and it can be difficult to remove, and the actual layer quality on the top is poor. Instead, let's leave it the same way that it was imported, so that the flat face is actually directly down on the 3D printer bed. Similarly, if I had this up like this, there will be limited area for the actual 3D print to adhere to the 3D printer bed, and that could cause issues related to the print falling over later. One way to fix that would be using a raft, but that really isn't necessary for this. So let's leave it in this orientation. As you can see, the edge of the 3D model actually has a slight radius. That means that there might be issues relating to the print actually peeling up at the edge as a result of it not being fully stuck down. While the Anycubic Ultra Base is quite effective at holding onto the print for PLA, it can still have issues related to warping if the bed isn't perfectly flat or if the first layer is put down a bit too quickly. There are default settings and a default setting for PLA. By default, the layer height will be 0.2 millimeters. That would mean to actually print an object a centimeter high, the machine would actually have to create 50 layers. And you can increase or decrease this resolution. A high resolution of 0.1 would provide you a higher resolution or a better aesthetic, or a better representation of your model, particularly on smaller parts or parts with curves. And draft would also be if you wanted to print it quite quickly, or if the overall aesthetic doesn't really matter. But we'll normally use 0.2 as this gives a good middle ground between print speed, resolution, and part strength. To begin with, wall thickness is what actually affects the strength of the part. There's a common misconception in 3D printing that it's about the infill. Adding a higher infill if your walls are quite thin typically won't give much difference. So for this part, the walls were, I think, 3.2 millimeters thick. So if I do a wall thickness of 1.6 millimeters, that will mean that this wall and the inner wall are both 1.6 millimeters thick, which will mean that there'll be a solid wall without a gap. If I had this less, if I had this as 1.2, then there may actually be infill in this area here, which would severely weaken the part and actually decrease the overall aesthetic of the wall as well. Importantly, the wall thickness is normally done in a number that's divisible by the nozzle diameter. So this one would have been designed for 3.2 millimeters because the nozzle thickness or the nozzle diameter we're using on the NdFeed i3 Makers is actually 0.4 millimeters. And so that would have been 8 wall layers. So let's leave the wall thickness as 1.6 millimeters. The top and bottom, let's increase that to 1.6 to make sure there isn't a gap. And for infill, we can leave that at 25%. Typically, there isn't much advantage of going past 30 or 40%. And then the next thing we need to look at is the speed. Essentially, the speed does affect the quality of the print. A slower speed normally gives better adhesion between the layers. And probably the most important aspect out of this is that the initial layer speed needs to be fairly slow. I like to do it at about 10 to 15 millimeters a second. That ensures that the plastic is pushed nicely down into the grooves on the Anycubic Ultra base and ensures that it sticks properly. And now we can go down to here and we can have a look at support. Although this part has these two overhangs here, support isn't really necessary. So I'll click to turn that off. And build plate adhesion. A skirt is essentially a test run around the print. So it basically primes the nozzle and it also allows you to show where it's going to print. It doesn't actually help with the adhesion of the part onto the bed. I like to use a brim, which essentially adds a little area at the edge of the part. And the brim width here is 4 millimeters or 8 layers. And if I go slice now and preview, we can actually see that this brim is this blue line around here. And that's going to help the print adhere. If we are having difficulties getting proper bed adhesion, especially for smaller parts, we could also use a raft. But that adds a lot of print time and adds a lot of material usage as well. So let's go back to the brim. And so once we're happy with this, we can look at the preview menu as I am now. And actually we can look at what's happening from the first layer onwards. We can speed that up. So it's doing the brim and then it goes and does the bottom layer there in the yellow. And now what we can do is we can look at the time as well. So this print's going to take about 3 hours. but you can, of course, speed it up and slow it down on the menu on the 3D printer itself. And it's also going to give us an amount of filament in grams, which is 26 grams, which is normally pretty correct. And now we can just go save to disk, straight to our SD card, or using an SD card adapter if you have one. And then you can go and plug that into the 3D printer